Yes, hi folks. Guys, today I will talk about further more reduction formulae. Okay. There are 4 more reduction formulae or maybe 2 more, six reduction formulae there. There are this one is also reduction formula. We can convert this also into reduction formula. 11th and 12th question. Okay. So I've taken these questions from students' queries as I always say, from online students' queries. Most of the students have replied me, asked me questions online. Okay. In class study, I've taken some of the questions because they can ask me in the class as well. So I have not taken most of those questions, but online questions are taken here, so that the students online who are not able to approach me easily, they can understand what is the process of doing these questions. Okay. These questions are, again, let me take based on some reduction formula. And the reduction formula, now this lecture will be my last one. Okay, the series of lecture. Okay, this will be the last one. After completing these 12 questions, I'll take next definite integral, okay, which is important chapter or important topic in case of the students' studies. Okay, so because definite integral without solving indefinite integral, we cannot solve definite integral. So definite integral, how to solve it, how to put the process of definite integral, that in the next series. But before that, let me take these questions. Now, reduction formula. First, let me take first question. So reduction formula. The reduction formula for plan of integration. This is E mx x raised power n into dx. This is the first question here. Question number 1. I've taken reduction formula for this. What is the reduction formula? In this case, again, integrating it by parts. For that, we have to take first function, second function. Now, considering the first function, second function in this case is very simple. It's the formula which I gave you in the previous, beginning of the by parts method. I just talked about that isolate formula is very important to consider the first function and second function. Right? What the first function and second function? For that, isolate formula is important. Isolate formula is important. Okay. Isolate formula is very important. In which I inverse function, logarithm function, algebraic function, trigonometric function, exponential function. So here we have this algebraic function, exponential function. First algebraic function, first function, second function, exponential function. The exponential function is the second function here. We have to consider this. So integrating it by parts, let me take integrating it by parts. We get taking, let me write here, taking e raised power mx as the second function, as the second function. Integrating it, this is equal to, therefore, let me write here, sign of integration e mx x raised power n dx. Now xn is the first function. This is the first function here. This is second function. Okay. Now, therefore, integration of e raised power mx dx minus sign ddx of, which is the basic formula for by parts method, full dx. Right. This will give us xn. I'm sorry. This is xn here. Xn e raised power mx upon n, a factor of function, the multiple of x here, dividing by multiple of x. Okay. So this is here minus sign. This is n into x raised power n minus 1 only e raised power mx upon n into dx. And let me take this as xn e raised power mx upon n minus n upon n, sign of integration. This is x raised power n minus 1 e raised power mx into dx. Now this is the reduction formula. This is the reduction formula here. This is the required reduction formula. This is the required reduction formula. Why reduction formula? Let me talk about it. This is a required reduction formula. Okay. Why? Because here the power is decreased. The index of x is decreased by 1. N minus 1, this is n only. Okay, here in the beginning it was n, x to the power n. Now it has decreased by 1. It is the formula is. Or we can write it as that in is equal to x to the power n e to the power mx divided by n minus n upon in minus 1. This is a reduction formula. First reduction we have okay. First reduction formula we have discussed here. In this series we have taken this is the first reduction formula. In this series this is the first reduction formula. Let me take the next reduction formula. Second one. Now what is the second reduction formula? The reduction formula for e to the power mx upon x to the power n. Second here, reduction formula for sum of integration. This is x to the power e to the power mx divided by x to the power n into dx, where n is greater than 0. This is the second question here. What is the reduction formula for this? Now if I take this, or it can be e to the power mx x to the power minus n here. Now try to understand. If I take this as a reduction formula, in this case ideal formula is reversed. The reason is that if I take x to the power minus n as the first one, alright, then it will be in the denominator, it will come out as n plus 1. But n plus 1 is not going to decrease the degree. So here we have to take x to the power minus n as the second function and e to the power mx as the first function. Here x to the power minus n is to be taken as the second function, not e to the power n. Reason is that here the power is to be decreased, but if I take minus n as the first function, it will be minus n, okay, and the power minus n minus 1. But when we take it in the denominator, it will be actually for n plus 1. That will be decreased, not decreased, but increased power. That cannot be reduction formula. Because of that, x to the power minus n is to be taken as second function for integration by parts. For integration by parts, as the index of x will be decreased when decreased, otherwise it will be increased. Now if we take as the second function only, then its index of x will be decreased, otherwise it will increase. That is, if we take x minus n as first function, in case fs x to the power minus n is taken as first function, if we take x to the power minus n as first function, then it will be increased. So we have taken x to the power minus n as second function. So integrating it by parts. Integrating it by parts, we get, what do we get here? It will be e to the power mx as it is. Integration of x to the power minus n into dx minus sign. This is ddx of e to the power mx into integration of x to the power minus n dx whole dx. It will be nothing but e to the power mx into x to the power minus n plus 1 on minus n plus 1 minus n. It will be n multiplication into e raised power mx, because m will come before after differentiation, into x raised power minus n plus 1 or minus n plus 1 into dx. Now let me further write it in proper manner. It will be 1 minus n limit e raised power mx upon x raised power n minus 1 into 1 minus n in the denominator over it 1 minus n, or if I write it as minus sign here, then it will be, let me write minus by minus n, write plus n with minus sign here. With the minus sign, let me write plus here, it will be n upon, this is minus sign I have taken from this, n minus 1. Sign of integration d mx upon x raised power n minus 1. Okay, so this I have taken as n minus 1. Now this is the reduction formula. Now let me further write it down. Minus e raised power mx upon n minus 1 into x raised power n minus 1 plus m upon n minus 1 sign of integration d mx upon x raised power n minus 1. Now here the power of x is decreased. This is reduction formula. This is the required reduction. Children require a reduction formula here. Okay, so this is the reduction formula. Second, let's go to formula. Second in this series we have taken second reduction formula. Okay, second is found. This is second question, reduction formula for second. Okay, now let me take next question again. So next reduction formula, let me talk about. Now question number third, which is also to be calculated for reduction formula. Third one, reduction formula. Sign of integration, this is x raised power n into log of x whole power n dx. Okay, now either formula is applied here. If it is not n power, negative n power n, then we cannot take it as, we cannot reverse Eilert formula. We applying Eilert formula, applying Eilert taking this logarithm function as first function, while L logarithm function, algebraic function second algebraic, logarithm first, taking log x whole power n as the second function, or as the first function, or as the first function, as the first function, and x m the second, and x m the second. Okay, so let me integrate it by integrating it by parts. Integrating it by parts, we get this will be equal to log of x whole power n as it is, x n integration is x raised power n plus 1 upon n plus 1. Okay, so this will be this one, minus sign, this is n into, but it will be log of, let me write n into log of x whole power n minus 1. into 1 upon x, differentiation of log x again, into x to the power n plus 1 upon n plus 1 dx. Let me write it further. It will be log of x whole power n, okay, x to the power n plus 1 divided by n plus 1 minus sign, this is nothing but n upon n plus 1 sign of integration log of x whole power n minus 1 into x to the power n here, because this 1 power and this n plus 1 minus 1, this will be dx and 1 into dx. Here we see we started with x to the power n, we have got x to the power n still, but n minus 1 has, n has decreased as n minus 1 has become as n minus 1. This is reduction form. This is the required reduction. This is the required reduction formula. Required reduction. Sorry. Required reduction formula. Okay, so this is the required reduction formula. Third one. This is the third question here. Okay. This is, we can write here that In is equal to log of x whole power n x to the power n plus 1 upon n plus 1 minus n upon n plus 1. This is the In here, In minus 1. Reduction form, because power is decreased, In minus 1. It can be written symbolically like this, or it's a required form. Okay. So this is the question number 12 we have taken. Now let's talk about next question. Question number 4, let me talk about. Okay. Now if I write this question, it is both sign of integration, this is xn, yeah, 1 log of x whole power n into dx. Now in this case, log of power minus n, it will be. Now in this case, we will reverse the what we call Euler formula. So whenever the power is to be decreased and it is negative, then it is to be written as minus n plus 1 upon minus 1, because the denominator we will take it as n minus 1. Just taken log of x to the power minus n taken as second function. If I write it as, let me write x to the power n plus 1 log of x whole power minus n upon x into dx. No problem. What I've done, I've multiplied by 1, x here in the numerator, and the denominator also divided by x. Now this is for integration. Now, by integration of, since integration of log of x, let me take minus n or whatever, it is minus n here, divided by x into dx, equal to how much? It will be nothing but log of x whole power minus n plus 1 upon minus n plus 1 only. Why this is? But if I consider log x as t, substitution method, 1 upon t, 1 upon x dx equal to dt, then it is t raised power minus n into dt. T raised power minus n is to be integrated t raised power minus n plus 1 upon minus n plus 1. Then substitute value of t here, which is log of x. In this way we have divided by x. It will be taken as second function of log of x n is to be taken as second function. Integrating in by parts and considering log of x is power minus n as second function. Then and on x also. This is x is power n plus 1 as first function. Okay, so that will be then reduction formula we have to find out. Okay, so let me integrate it by parts. Integrating it by parts. We get, what do we get here? So we get here x raised power n plus 1 as it is. Sign of integration, this is log of x whole power minus n upon x into dx. Minus sign, it will be differentiated as n plus 1 x raised power n integration of the same value log of x whole power minus n upon x into dx. Okay, into whole dx. Now let me put the integration value of this. If I take log x as t and 1 upon x dx is dt, t raised power minus n into dt. Integration with t raised power minus n plus 1 upon minus n plus 1. Directly I am writing here. Take or put log of x equal to t before 1 upon x dx equal to dt. Therefore it will be that we have x raised power n plus 1 now integration t raised power minus n dt integration n plus 1 now integration x raised power n integration of t raised power minus n into dt whole dx. This integration is x raised power n plus 1. It is nothing but then t raised power minus n plus 1 upon minus n plus 1. That means t raised power here, that is log of x whole power minus n plus 1 upon minus n plus 1. Okay, minus n will be n plus 1. Out of integration x n. Again, this is log of, putting the same value, log of x whole power minus n plus 1 upon minus n plus 1 into dx. Now let me take minus sign common here. Be minus x raised power n plus 1 upon n minus 1 log of, it is here, sorry, log of x whole power n minus 1. Why? Because this power minus n becomes positive in the denominator and 1 will become negative. It is power n minus 1. Okay, minus sign, this will be plus sign. Take minus sign common here. So it is nothing but n plus 1 upon n minus 1. Then sign of integration, this is x n upon log of x whole power n minus 1 into dx. This is a formula n minus 1 because reduction is there. The power of log of x. There is reduction from n, it has become n minus 1. From n, it has become n minus 1 in the denominator. Because of that, this is the reduction formula, which is the required reduction formula. Here, this is the required reduction formula. This is the required reduction formula. This is the required reduction formula. Got the point? This is question number 4. We have done. So, 4 reduction formula, we have found out the process is. In this case, I did formula in reverse. Reason was log of x whole power minus n by there. Because that we have taken the reverse value. Then first consider this as second function. Otherwise, it is considered as first function. Then another function is considered as first in case of islet formula. But in this case, this is reverse. Reason is minus n power there, which is to be reduced. We have to find a reduction formula. Okay, because of that, we have taken this. Now, question number 5th. Let me talk. What does question number 5th say? Let me check. Okay, now question number 5th. Okay, now it says limits 0 to infinity, right? E raised power minus x into x raised power n into dx is equal to factorial n. This we have to prove it. Okay, this is prove it. I'm sorry. This is to prove it. So we have to prove it that this is value is factor. Now let me take this value, integrating it by parts. Now we are taking pilot formula, no problem. Taking the pilot formula, by that ex e raised power minus f or e raised power x is second function. Taking integrating it by parts, taking left hand side first. Left hand side here. Left hand side is 0 to infinity. E raised power minus x, x raised power n into dx. First integration. Integrating it by parts and taking ex as second function, e raised power minus x. This is Euler's formula we are applying and the second function. Okay, second function by Euler's formula. Euler's e last, exponential function last, second function, and then first is algebraic a e, inverse function, logarithm function, algebraic function, trigonometric function, exponential function last. Okay, so this is the logic here. Now let me take integration of this. So what do we get? This is x raised power n, integration of e raised power right minus x into dx minus sign into n into x raised power n minus 1, differentiation of x raised power n into x raised power n minus 1, into integration of this would be e raised power minus x upon minus 1 into dx. We have integrated this. Now here it is minus x raised power n into e raised power minus x. Okay, now limits are to apply 0 to infinity. It is 0 to infinity. At both of these we have to apply the limits. Here let me write 0 to infinity minus sign minus 1 plus here for n into 0 to infinity x raised power n minus 1 upon dx positive value. Here also we can write it as minus x upon e raised power x minus sign here 0 to infinity plus sign, this is n 0 to infinity. Okay, let x n minus 1 e raised power minus x into dx the same function. This is the second function. Now let me check. What is the value of this? What is the value of this? Here also we have to apply 0 to infinity. Okay, so this is the function here. After integration, we have obtained this function. Now let me check this. Now x upon, sorry, this is x raised power n, x raised power n upon dx. Okay, so let me show that this is equal to 0. How it is 0? At 0 it is 0, no problem. Lower the bit, but at infinity, what is the value of this? Let me solve it here. Now, limit x tend to infinity. X raised power n upon dx. Let me find out this equal to what? 0 to infinity. This is equal to infinity upon infinity form. This is the infinity upon infinity form, indeterminate form, or indeterminate form. We have to make it determinative. Okay, so this last equation leave and remove this. So what is the value of this? So we have to just extend this. So let me write it equal to limit, or limit if I am writing here, no need of writing this here. Okay, so limit extend from writing only infinity. At infinity, what is the value? At 0 it is 0, no problem, because x 0, the 0 is 0. 0 upon e 0 is 1, so 0. That's 0. But at infinity, what is this value? Let me check it. So this can be written as xn. If I expand ex exponential function, it will be 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 plus and so on. It is xn upon factorial n plus xn plus 1 upon factorial n plus 1 plus and so on. The end will be 1 upon factorial 1 here and so on. So this is infinite terms. Series is up to infinity. Now let me divide numerator and denominator by xn. Dividing numerator and denominator by x raised over n. We get what we get here. This limit x tend to infinity. X tend to infinity. It will be 1 upon. This will be 1 upon xn plus it will be 1 upon x minus 1. X raised power n minus 1. This is 1 upon x n minus 2 into factorial 2 here, no problem, and so on. This will be 1 upon factorial n step plus it will be x upon factorial n plus 1 and so on. What will we get here? It is 1 upon infinity is 1 upon infinity 0 upon 1, or 1 upon 0. It will be 0 will come in the numerator. Okay, so 1 upon infinity, that means infinity is 1 upon 0. 0 it will be equal. It will be equal to 0. Why? Because this is 1 upon infinity. X tend to infinity by itself. 1 upon infinity is 1 upon 0. 0 will come in the numerator. 0 upon something. 0. First part, this is 0 here. Therefore,